we have two identical discs. This disc is also working like a pulley, which is fixed to this rigid support. Our string is wound over here, and this is other disc over which the string has been wound. Now this is released. When this is released, so obviously this will be going down with some acceleration. We are asked with what acceleration this will come down. Both the discs have the mass, same mass and same radius. If we draw the force diagram for this, it is T is in this direction for this, T is in this direction, and mg for this, it is in this direction. If we write the equation for this one, so it is only rotating, so we are going to write equation only for rotational mechanics, that is torque about O. Let's find torque about O, and we'll put it is equal to I into alpha, right? So when we say torque about O, this is T, this is R, so torque is force into perpendicular distance with line of force and acceleration. This is line of force, this is acceleration, this is perpendicular distance, that is equal to R, so T into R, that is torque. But torque is also equal to I into alpha. About the same axis we have to find torque, about the same axis we have to use I, about the same axis we shall be getting alpha. So I about this axis we have said that this is a disk, so that is we can take mr square by 2, about IO we can take it as mr square by 2, moment of inertia about this axis. So T into R is equal to mr square by 2 into alpha, right? The acceleration of this point, if we say that the acceleration of this point is A1, so we can write T is equal to R, and this will get cancelled, mr by 2 into alpha. Alpha is obviously, that is for this, A1 is equal to R into alpha. This is going to have some alpha, and the tangential acceleration of this point, A1 is equal to R alpha, that is connected like this. So alpha is equal to A1 by R. So let's put it over here. Alpha is equal to A1 by R. So T is equal to M A1 by 2. This is one equation we get. So now if we talk about this disk, this shall be unwinding like this, that is alpha is going to be like this, and this shall also be moving down with some acceleration, that is center of mass shall be moving down, let's say with the acceleration A2. So if we talk about this shall be moving down with the acceleration A2. So linear mechanics equation is going to be, because this is going down, so mg minus T is equal to m into A2. This is the equation. Apart from this, if we take the torque equation about A, about this we take, so torque of this force about this axis is equal to 0, because that's passing through the axis itself. So for this, torque about A if you have to find, so it is T into R is equal to I, that is T into R, it shall be rotating in this direction, alpha will be in this direction. So T into R is equal to I is mr square by 2 into alpha. So here what we see is absolute acceleration of this center of mass is A2 is in the downward direction, thread acceleration is A1 in this direction, this is a continuous thread. So acceleration of this point, this point, this point, this point, absolute acceleration is A1 of this point also, which is situated on this circle also. A2 is greater than A1, so that's why alpha is going to be in this direction. So if we intend to write equation A is equal to R into alpha for this body, for this revolving disk, so it is going to be A2 minus A1, that is relative acceleration, this one is greater than this one, is equal to R into alpha. So we put alpha over here. So it comes out to be T into R is equal to mr square by 2 into alpha is what? Alpha is A2 minus A1 by R. R square it get cancelled. T is equal to A2 minus A1 by 2. So we get this. So from here we get T is equal to M by 2 A2 minus A1. So this is one equation we get. So how many equations we have? We have T is equal to M1 A1 by 2, Mg minus T is equal to Ma2, and this is T is equal to M A2 minus A1 by 2. So now we have three unknowns. T is unknown, A1 is unknown, and A2 is unknown. So we have three unknowns and we have three equations. We can solve these three equations to get the value of A1, A2 and T. So now we have three equations. T is equal to Ma1 by 2, Mg minus T is equal to Ma by 2, and this is the third one. And if we are interested in finding the value of A1, so A1 is A2 by 2, A2 is 8, so this is 4 meter per second square. So this center is going down with 8 meter per second square, and this end is going with 4 meter per second square.